ahead and get started with the last chapter in Unit 3, and that's on the present value of investments. So today we're going to calculate the present value of a single deposit investment, and then we're going to calculate the present value of a periodic deposit investment. So the difference in that, you heard single deposit investment. That means that somebody wants to know, how much do I need to put in the account now so that at some point in the future, I will have the amount of money that I need. A periodic deposit investment is how much do I need to be putting into the account on a regular basis so that I can reach that value at some time in the future. So the first thing that we're going to do is go through a single deposit investment. So it says here that Mr. and Mrs. Johnson know that in 6 years, their daughter Ann will attend state college. She'll need about $20,000 for the first year's tuition. How much should they put into the account that yields 5% interest, compounded annually, in order to have what they need in 6 years? So we still have the same BPRNT, and they all still mean exactly what they have in the past. B is ending balance, P is principal or beginning balance, R is rate as a decimal, N number of times compounding, and T time in years. So we're looking at a $20,000 final balance. We don't know the principal. The rate here is at 5%, and it compounds annually, and we're looking at 6 years. So we need a new formula because we're actually solving for principal, the principal balance, not the ending balance. So that new formula looks a little bit like this. It's principal equals the balance divided by 1 plus the rate divided by the 9 times compounded, all to the times compounded times time. So let's plug in our values. Principal is what we're looking for. $20,000 is my value for my balance. 1 plus 0.05 divided by 1, all to the 6th power. So let's go ahead and plug that into the calculator. I'm going to move the calculator over here. And we've got here 20,000 divided by, I'm going to open a parenthesis, 1 plus 0.05 divided by 1, close parenthesis, to the 6th power. And I get a little bit off there, so let's try this one more time. So the value is 20,000, and that might be my problem. I'm putting in 200,000, so it's 20,000 divided by 1 plus 0.05 divided by 1, all to the 6th power. And there we go. We've got 14,924.31. So 14,924.31 is what they need to put into the account today so that in 6 years that will reach $20,000. All right, for the next one it says, for how many years would it take 10,000 to grow to 20,000 in the same amount, same account? So all of the values that we had before are the same. It's 20,000. I'm going to skip over the principal here for just a second. The rate is 5%. It compounded 1 time. And let's think about this logically before, because really what we're going to do here is we're going to guess. We're going to estimate when we think it's going to be. Well, after 6 years, they earned a little over $5,000, and they need $10,000 to actually build to $20,000. So, didn't quite earn what we needed with the 6 years, so if we double that, putting that into the formula, it would be 20,000. Remember, our goal is to have principal be 10,000. So 1 plus 0.05, all to the 1, all to the 12 power, because it's 12 years now. So let's see what 12 years yields us. We've got 20,000 divided by 1 plus, let me go back here, 20,000 divided by, open parenthesis, 1 plus 0.05 divided by 1, all to the 12th power. 11,136, so not quite. We aren't quite there. So let's try a little bit longer value. Why do we need longer? We need to be able to put in less money, so it's going to take longer for that to yield out to 20,000. So let's add a couple of years and let's try 14. So we've got 20,000 divided by my 1 plus 0.05 divided by 1, all to the 14th year. And if you look at that, we're about as close to 10,000 as we're going to get. And so the answer here ends up being, it's going to be about 14 years for 10,000 to double to 20,000. All right, next example. Rakita just graduated from college, and she needs $100,000 in her savings account. She wants that in 10 years. How much must she deposit into an account now at a rate of 3.8% that is compounded daily? So my question mark there is on principal. Plugging into my formula, I've got 100,000 divided by 1 plus 0.038 divided by 365, all to the 3650 power. And that was 365 times 10. Plugging that into our value here, let me move this down a little bit. We've got $100,000 divided by 1 plus 0.038 divided by 1, all to the, actually, start that over, sorry, I hit the wrong one. So 100,000 divided by 1 plus 0.038 divided by 365, close parenthesis, and that's going to be to the 3,650 power. So let's try this one more time. 100,000 divided by 1 plus 0.038 divided by 365, all of that to the 3,650th power. And there we go. $68,387.49 is how much needs to be placed into the account now to yield $100,000 in 10 years. All right, please press pause, solve this equation. When you're ready, press play, and we'll get started. Okay, let's see how you did. So, again, putting my BPRNT over on the side, let's identify that it's still going to be $100,000. It's still at a rate of 0.038. The difference here is it's going to compound weekly instead of compounding daily, so it'll be 52, and again for 10 years. Plugging that into my formula, I've got $100,000 divided by 1 plus 0.038 divided by 52, all to the 520th power, because it's 52 multiplied by 10. So, starting here, I've got $100,000 divided by 1 plus 0.038 divided by 52, all to the 520th power. And if you look here, it's not much difference. It's $68,395.63. So we're looking at a difference of about $8. All right, last example that we'll be doing for this unit. Nick wants to install central air conditioning in his home in 3 years. He estimates that the total cost of this is going to be $15,000. And he must deposit into it monthly. So that's kind of your key thing here, is it's saying that he is going to make multiple deposits. He's going to put it in every month. Pays 4% and he knows that in 3 years is when he needs it. So we've got a new equation again, a little bit more involved than the previous one, but very similar. So it's principal equals the balance times the rate divided by the number of times compounded, all over 1 plus the number of times compounded, the rate divided by the number of times compounded, to the number of times compounded times the time minus 1. So plugging those values in, we knew that it was $15,000. So I've got principal equals 15,000 times the 0.04 divided by 12. All of that over 1 plus the 0.04 divided by 12, all to the 36th power. And I got that by multiplying 12 and 3, which is my n times my t, and then subtract 1. So, breaking this down now, let's figure out what we've got. So we have $15,000 times 0.04 divided by 12. And that equals 50. So the top is 50. Divided by, open those parentheses, we have 1 plus 0.04 divided by 12, close parenthesis, to the 36th power minus 1. And again, let's try this again. So 50 divided by 1, let me use 50 divided by 1 plus 0.04 divided by 12, close that parenthesis, all to the 36th power minus 1. And I think I'm just doing this in the wrong order. So what I'm going to do is go ahead and calculate the bottom first. So we get 1 plus 0.04 divided by 12, all to the 36th power minus 1, and I get that value. I'm going to put this into my memory, and I'm going to pull up what was on the top, which was 50 divided by my memory recall, and I get $392.86. So you can see that there's more than one way to skin a cat. If you cannot get what seems to make sense. Before we had an answer of 34, that made no sense. So we need to be able to identify that and to make changes. So breaking it down so that we solve the top and then the bottom and then do the dividing, that might be another way to look at solving. And that's it for this unit. Great job on finishing Unit 3.